Hey everyone, Matt here from LimaCharlie, and today we are going to continue our LimaCharlie 101 series by focusing today on detection and response rules. This is perhaps one of the most pivotal and crucial things to understand about LimaCharlie because it's really how you utilize the true power of the platform and all the different types of telemetry that you have coming into the environment. So I'm looking forward to this one. This is going to be a really interesting session, I think. First off, this is a continuation of our previous LC101 session. Just in case anyone is curious or you are not really too sure, Matt, what are you talking about there? About 2 weeks ago, 2 or 3 weeks ago, I can't remember the date exactly, but we kicked off our LC101 series, which the first video was setting up an organization, installing sensors, and really getting familiar with the idea of telemetry from a LimaCharlie perspective. I mentioned it last time and I'll mention it today as well. Telemetry is really what guides and empowers any security team that's out there. Telemetry is your insight, your visibility, your data, your what's going on, what's happening, what are we doing, what's out there. Telemetry helps answer all those different types of questions. So as we mentioned in our first session, when it comes to telemetry, I'm going to want to bring any and everything I can into the LimaCharlie platform, from our EDR sensors, Mac, Windows, Linux, Chrome OS, Docker, Edge, all the way to third-party log sets, cloud data sets, whatever else might be out there. I'm going to want to connect and bring in every single data set that I can. If you're in like a 24/7 monitoring role and you've got maybe a handful of customers or you work in a SOC for a single organization, you're going to want to have all that telemetry in one place just in case you need to investigate something, there's an error that needs to be dealt with or anything else along those lines. And the aspect of a incident response, for example, where things are a little bit different, in that case, you're going to want to have all the data in one place so you can investigate and see what's going on. So you can really get into what's happened in this environment. What do I need to investigate? What was the root cause? Where's my malware, impacted users, so on and so forth. Having access to more data is going to be critical for that. So getting data in is the first part of utilizing LimaCharlie, and perhaps, as I mentioned, one of the most important. What you do with that data, how we utilize that data to our advantage is the next step, and that's where detection and response rules come in. Now, let me first maybe reset the idea for a lot of you about what detection and response rules should be or are supposed to be, because sometimes we get into some really interesting discussions. I think a lot of folks think that detection and response rules are strictly to find malware inside of an environment. And while that's probably 98, 99% true, I'm going to go and say it's not the only use that we have for detection and response rules. In fact, I would go a little bit further and I would say with all of the telemetry that I've got in one place and all the telemetry I can bring into one place, how can I utilize that telemetry to answer questions? And in LimaCharlie, detection and response rules are how we go about answering those types of questions. What I mean by that is the data that comes in is a very, very large volume. The questions that we have are often finding needles in haystacks of that volume. So I might be asking a question such as, how many different services have been installed, or how many different PS exec services have been installed, for example. I may be asking a question such as, how many times has the MAT user logged into a system? What other systems has the MAT user logged into? Things like that. Those are questions very typical of a SOC or of an IR team, but those are questions that are very much needle in haystack because you're drilling or digging through millions of lines of telemetry, millions of rows of events, if you will, looking for hopefully just a handful of things. The other side of that is I do not want to be going through all that data manually. I want to find an automated way to go through it. And I want to have the computer tell me when something happens. So again, hypothetically using that same example, if I'm interested in every time the MAT user logs into a system, I'm not going to task an analyst of mine to go and dig through logs every single night and see where the MAT user logged in. I'm going to automate that, and I'm going to write a detection and response rule that goes and says, if MAT logs in, fire an alert and let me know. So what we did there is we just kind of changed what we think about a detection and response rule. I didn't say anything about the MAT user being malicious or suspicious. I just said it's a question that I want to answer. Now, let's put the asterisk on that and just say, yes, the MAT user is compromised. Boom. Now we've got a detection of threat actor activity. But if I take that asterisk off, I'm simply going to answer a question. That's the detection side of things. The response side of a detection and response rule is really where I think the LimaCharlie platform shines above many others. And I'm a little biased, of course, in my opinion of that. But my main reasoning for that is when I think of a detection and response rule, a lot of folks out there are used to detection rules. They're used to detection engineering. They're used to just simply crafting a detection for a thing. And then once that detection is fired, it then falls into the processes and the workflows and the workbooks and the playbooks and everything that have been defined by the SOC or have been defined by the IR team, and they kind of take it away from there. One of the things that I don't necessarily like about that approach, now I'm not saying it's a bad approach because it's how most SOCs out there operate, and it is one that works in a way. But I feel like there's a level of automation that can be attached in that response side, or perhaps maybe a little bit better discerning metadata can be associated with these things. And what I mean by that is if I write a detection and that detection carries with it a certain sense of false positivity or a certain sense of fidelity or a certain sense of risk, or it means a certain thing, or let's say perhaps it is a priority 1 versus a priority 5. Let's say if it happens on a very important or a crown jewel system versus a user workstation, my response might be a little bit different. I want that metadata and I want those things captured inside of the rule itself. I don't necessarily always want to have rules and responses separated. And we'll talk about what that means. But the second part of a detection and response rule is that response side. And very simply put, the response side for me is, what do you want to do when that thing is detected? Sometimes we just want to notify. We just want to say, hey, just fire an alert up that says the user Matt logged in. There he is. That's it. All said and done. Other times we might want to say the user Matt is compromised. If the user Matt logs in, I want an email to the top 5 people of this investigation. I want you to isolate the system from the network. I want you to add some additional metadata, to add some tags to it. I want you to kill the process that they're using or anything along those lines. Notice how I want to escalate those different steps, a lot of times at the detection level, because I'm very close to the source or to the event that actually took place. And let's finally talk about the aspect of time in this case. And it comes to a detection and response rule, timing, or how close you are to the event, is one of the most important things you can possibly have. That is your advantage as a defender or as a blue teamer or as a security analyst or as an incident responder. Time is your advantage. So if I am crafting a detection rule, and it's a really, really good detection rule, and every time something malicious happens, it fires, and that detection fires and that alert goes up somewhere, wherever, where my analysts receive it, and then my analyst takes 5 minutes, 10 minutes, 1 hour, 2 hours, maybe never even sees that alert come in. I just gave up the element of time, or I just gave some of it away to my adversary. And I never want to get in a position where I'm giving my adversary my time, because it means they're winning. They've got the advantage then. So the other nice thing about when we bring response actions right next to the detections is I'm keeping the advantage of time on my side. Now, there are quite a few automated playbooks or automated frameworks or SOARs out there that might help you do this. But again, I want to do as much as I can within one platform. And you're going to see that today as we kind of walk through and talk about detection and response rules from a LimaCharlie perspective. All right, so just to kind of summarize, that's like my lecture beginning, if you will, is understanding the idea of what a detection and response rule should be and how we should be utilizing them. So let's recap. The detection side, I am wanting to detect something amidst, I'm looking for a needle in a haystack. I am looking to detect something amidst a lot of different noise. The response side of it is simply put, what do you want to do when you find that thing? How would you like the system to act once that thing has been notified? And then last but certainly not least, how can I deploy these detection and response rules to be effective inside of my environment? All right, that's what we're going to take a look at today. So you've hopefully noticed that my video has already got my LimaCharlie demo instance loaded up, and I'm going to move myself down to the corner just so my head's not in the way as we're talking through this today. But we're not going to spend too much time in the sensor side of things, except to walk through some different events that might come through. But before we do that, I want to draw your attention over to 2 different parts over on the left-hand menu bar, the left-hand pane. The first is going to be the detections. This is simply put where your detections are represented once something has been detected. So a thing has been found according to your rules. This is where that thing is going to show up. We'll come back here a little bit later. We don't want to be there just yet. Where I want to draw your attention to first is going to be under automation, the detection and response rules area. This is going to be the place that houses all of the different detection and response rules you've got created or you've imported or you've added on to your instance. And most times they're going to be listed based on, I think the first order is going to include things that your organization has created. We'll talk in just a moment about some of the additional data sets that we can import. But notice I've got 887 rules in this case right here. Folks, I did not write 887 rules. I'm going to talk to you about how you go from zero to hero in just a moment here. But the detection and response rules side over here is my hub. This is where all the different things that are going to be detected inside of my environment are centrally located. Now, there's obviously a couple of different things to be aware of. If I have any draft rules that I've been working on, let me zoom in on this a little bit. If I have any draft rules that I've been working on or things that my team has been building out, they're going to be available here in draft, as I'm sure you can obviously see. Any rules that are currently written or have been published being the key word there, rules that have been published are going to be represented without the draft notation, if you will. And then I've also got to the right-hand side, the ability to either enable or disable those rules depending on what my organization needs. In this case, you'll see that this Black Matter Dark Side ransomware is disabled. My enableds all have the blue to the right-hand side. So that's the easiest way to go through and see what's enabled, what's disabled. And obviously anything that I'm looking at or talking about today is available via the API, but we're going to stick inside of the web app for just today. All right. So we know where our detection and response rules are located. Let's talk about first the detection side of that, the D in the DNR rules, if you will. I always like to reference our documentation when I'm talking about detection and response rules, just because it does a really good job of laying out and describing all the different pieces of this. First and foremost, and you can see kind of why I talk the way I do about this, every rule has two YAML descriptors, one to detect and one how to respond. So those are the two things that we're going to walk through. There's a basic rule here. We'll come back to that in just a moment. One of the most important things to orient yourself with if you are writing or wanting to write detection and response rules are going to be the different types of events that the sensors can generate, and then the different types of actions that you can have in the response. But hold on, Matt, whoa, that was way too fast. We are barely 13 minutes in and we're already moving right in towards detection and response rules. That's not where I want to be. I just want to turn some things on and start finding malicious activity in my environment. There's nothing wrong with that either. This is where I think the beauty of our platform comes into play. So let me backtrack. You may have noticed I said I've got 887 rules here. I did not write 887 rules. There are some which have been written for my organization, but take a look. If I scroll down a little bit, I get into some different types of rule sets that are down here. Now, they are updated by one of my colleagues over here at LimaCharlie, so we won't spend too much time on that, but take a look. There's a subset of rules in here known as _soteria-rules. We've also got, if I scroll down a little bit further, hopefully we will come across and potentially see what I think are going to be, these are Soteria rules. Let me see if I can't zoom in on one of these. Okay, good. We've got a really healthy Soteria rule set inside of here, which is fantastic because it's going to, well, we're going to talk about what Soteria rules are in just a second. But you might notice in this case, I've also got _Sigma. And these are Sigma rule sets that have been ported into LimaCharlie and are made available inside of the environment as well. Let's talk really quick about managed rule sets. Before we go down the road of writing our own detection and response rules and bringing those out, let me talk about really fast and easy ways to get detection and response rules loaded in your environment. So, as I mentioned, we had a couple of other different rule sets in here. We saw the word Soteria and we saw Sigma inside of there. Soteria is actually an organization that LimaCharlie has worked with for a very long time. They manage and publish their own rule set inside the LimaCharlie marketplace. You may notice I had some of those. We were viewing them earlier. Take a look. This Soteria rule set is managed by Soteria, which means there are some really, really great folks kind of behind the scenes keeping an eye on this rule set, number one. Number two, the other really nice thing about it is there's hundreds of rules in there primed and ready to go. Already in LimaCharlie format, I don't need to be writing or touching any YAML whatsoever. All I have to do, now it's turned on for me, but in your instance, if you went over to add-ons, rule sets, Soteria rule set, you would simply select your organization and hit subscribe. There is a nominal cost for Soteria rule sets, but it gives you a nice curated rule set which goes against these events. We're going to talk about events in just a moment here. Notice that there are rules available for Windows, Linux, and Mac, which is a fantastic coverage set. But more importantly, the nice thing about this here is without any detection engineering space, without any insight, because the moment I started saying, let's write 2 YAML descriptors, detection and response, you might have stood back and say, whoa, that's a little too fast. I'm not trying to go down this road. I'm not trying to write all these detection rules myself. I'm going to say, great, with LimaCharlie, you don't have to. You've got the ability to bring in a rule set like Soteria. Now, Soteria does have that cost associated with it. We also have an open source support as well in the form of Sigma rules. For anyone who's not familiar, the Sigma project is, and I'm going to zoom in this one really quick, a generic and open source signature format that allows you to describe and find evil inside of log events. The Sigma rule set is a rule set that is maintained by the open source community. I will say it was updated 2 hours ago as of as of this recording, or as of this webcast, if you will. And the nice thing about that is it is a standardized rule set that can subsequently be ported into a multitude of different places. So if I'm utilizing LimaCharlie or maybe a third-party data sim or some other data aggregator, Soteria rules are where I would, Sigma rules are a open source rule set that I could port in and use to start to detect malicious activity. You can turn those on for free. There is a little bit of a back-end service. It does not impact you as a user whatsoever, but there is a back-end service where we go and we pull rules. They are converted and then subsequently brought into LimaCharlie as well. And we take care of all that. But once you go ahead, again, if you were to select your organization and hit subscribe, you would have Sigma rules turned on. And I just want to pause right there, because between Soteria and Sigma rules, you've already got a huge jump start. But we've recently, and in the past few months this came about, we've also got a partnership with SnapAttack, another fantastic organization out there building detection rules. They've got another rule set, the SnapAttack Community Edition, that can also be immediately turned on or subscribed to and implemented into your organization. So let's go back and take a look at that really quick. We've got Sigma, Soteria, SnapAttack. There's also SOC Prime in here as well. Now notice this will require an API key in this case, so you can subscribe to SOC Prime rules if you have a relevant API key and which type of content you'd like to bring in. There is also a LimaCharlie sponsored generic Mac OS rule set, but long story short, folks, I can go back to LC101, our first episode. I can create an organization, install a sensor, hop over to our marketplace, and turn on detection rules without skipping a beat. What I mean by that is before I even install a single sensor or a single agent or bring in a single data set, I can already have detection rules up and running in the background, ready to receive whatever data I send in. I don't have to have a detection engineering background. I don't need to know how to write any code. I don't have to bring anything together. I don't need any custom knowledge of how malware works. I can go from zero to hero really fast with 5 very capable rule sets. Again, some of them free, some of them with a nominal charge per sensor. But the nice thing about that is I can get these turned on for free, get them implemented for free, and I now have a functioning detection and response engine. But I've got to stop and pause there. Now you see why I talk about detection and response in 2 different parts. These right here, these rule sets are great. They're a fantastic integration. They will help you they will detect malicious activity inside of the environment. But they do not come with, or they likely don't all come with, integrated response capabilities. Meaning, in the beginning, when I talked about that, what do you want to do when I find something, or when the computer finds something, that part is still up for you as the user to decide, for you as the analyst to decide, for you as the organization. So I cover going or importing different rule sets first because it keeps us in that detection space, but it does not move us to that response space just yet. And it's also a really good segue into, you know what, Matt? I like Sigma rules, but they're very generic. I like Soteria rules, but they're very generic, or there's a lot of them. We have special niches or special things inside of my environment that we need to look for. We have special applications, special user permissions, special agreements, special operating system spread, different third-party log sets. I want to write detection rules against all of these things, and I don't think any of these generic formats are going to fit in the things that I need. Awesome. We, of course, also give you the ability to integrate and implement your own detection and response rules, which is what we'll head over to and get in now. So again, we covered bringing in external rule sets to get you started and get you going really, really quickly. I believe our quick start guide and our documentation actually talks about turning on Sigma rules without even writing your first rule. It's, again, a great way to start. It's a couple hundred rules or a few hundred rules that get dropped in. I'm finding malicious activity, again, without missing anything. So it's a good way to start, a really good way to start. That being said, let's get into the custom side of detection and response rules, or should I say, let's get into the, customized detections, customized response actions. Because one thing that we can't do in some of those managed rule sets is I can't necessarily go and change what happens from a response perspective. So you may notice if we come down here, for example, to the Soteria rules, the Soteria rules are available. They work inside of the environment. I'm able to use them to find malicious activity. In this case right here, I'd be looking for a mega non-standard directory. However, the content of the rule itself is proprietary. Therefore, it belongs to Soteria rules. And even though I'm using the rule, I can't go in and modify the contents of the rule. I can't change the response side of it. So what normally happens with a lot of LimaCharlie users is you can utilize rules or rule sets or imported rule sets to quickly get up and running. But then you're going to find, wait, I want to do a little more. I want to have different response actions. I want to look for activity that's a little bit different. So we'll get into writing custom detection and response rules. I'm going to bring back over our documentation. We're going to focus on a basic LimaCharlie rule just to talk about kind of what's happening in this space. Now, remember, as I said in the very beginning, a detection and response rule is 2 YAML descriptors, what to detect and then what to respond. I'm going to bring up a rule that we're going to come back and talk about. In the web app, these two things, these two components are going to be separated. So you've got your detect up here at the top and then your response down here at the bottom. Those are going to be separated for you. You can also write and import rules just as a YAML file or as a detection and response file, and the system will know what to do with them. Nonetheless, I like to talk as them first as one object, and then we'll break them apart when we write them. So our basic detection and response rule that we can see right here, this one's pretty straightforward. Let's walk through what's happening here so we understand some of the contents. First and foremost, again, the detection side. The first or some of the key things that I need to have are, first off, what event do you want to trigger against? What type of thing are you looking for? Again, we're using detection and response rules to answer a question. The starting point of writing any detection and response rule is going to start with the event of interest. What I don't want to do is I don't want to throw if you're familiar with SQL, I don't want to throw a select star against my data. I don't just want to run across everything. Let's drill into this one a little bit further and I'll show you what I mean. In this case right here, our event is a DNS request. We are telling the rule my operator is, which means this is, and then the operator corresponds to the subsequent values below. So in this case, my detection and response rule is based off a DNS request, and I am looking for instances where the domain name, domain underscore name inside of the event is example.com. Or in layman's terms, I am looking for every time a DNS request is made for example.com. Remember, we're going through and we're asking our telemetry questions, and we do that with a detection and response rule. So again, I am looking for every time example.com hits in a DNS request event. Now, there's a couple of things, first off, we need to break down about this. Number one, Matt, how did you know what types of events are available out there? We'll get to that in just a moment. Number two, Matt, how do we go through and kind of put the different operators together, and how does that work and things like that? Well, there's a couple of explanations inside of here, a couple of ways to walk through them. You're more than welcome to spend some time reading through this documentation. We actually do have some focuses specifically on operators that can be used. However, I'm going to come back here and keep it really straightforward, and I'm just going to say your operator is something that helps qualify the different things or things that you're looking for. Let me give you an example. Let's say I was looking for every time someone reached out or tried to connect to the site example.com. I'm looking for a DNS request for example.com. That rule is pretty straightforward. But let's say I was interested in every time a person or a user reached out to example.com or example.net. Did you notice how my operator changed? I'm no longer saying is, but or. So what we would have in that case, if I hop over to my operators, if you will, my operator in that case would be or. So what I tend to find to be really easy when you're writing detection and response rules is maybe not to think of them necessarily in YAML breakdown, but instead first ask that actual question out loud. What am I looking for? What am I looking for? I am looking for every time someone connects to example.com or example.net. If I say that statement out, guess what? We've pretty much answered every single thing that we're looking for. The only technical term inside of that we need to have figured out is where is the event and where is that path located? And we're going to break that down here just now. So I already have an idea of how to utilize operators and the things I'm looking for. Quick note, there are a bunch of different operators available in LimaCharlie. Folks, this is not advanced detection and response, so we won't go through every single one. I'm just going to say that some of the operators tend to go down a really nice programmatic path. There are regexes available. We can do things like contains, starts with, ends with. If we're matching against numerical data, we can do greater than or lowercase. There's that matches with a regex that I talked about just a moment ago. We can also utilize things such as CIDR notation if we want to. We can check if something is a private address or a public address. And again, what I'm doing is I'm using the technical operators here to help me answer that question. So again, I'm interested in every time someone connects to example.com or example.net. I can expand my question a little bit further if I want to. I am curious every time a user connects to a system from an external IP address. Well, again, you've just kind of answered your operator in there, from an external IP address, aka a public IP. So the more you kind of pronounce your detections as questions or say them out loud to yourself, and I've even gone down the road of writing them out or typing them in when I write a detection out, that I find out that a lot of the details I want and a lot of the operators I need are in the English version of writing that question. And then you simply just translate that over. Let's stick with the detection side right now. The next part I want to focus on are the events. Meaning, okay, Matt, great. I understand the operator. I want to find every time someone connects to a domain or looks up a domain, how do I know where those domain events come from? How do I know what they look like? And what I'll do is I'll point you over to, and it's inside of our documentation, reference events. Inside of our reference events page are all the different types of events that are represented in LimaCharlie from an EDR perspective. Let me be very clear. These are sensor events. Right now, we are writing against sensor events. Let's break down the difference before we keep going. Remember I said at the beginning of this, and in a lot in our last session, LimaCharlie succeeds and you succeed on telemetry. Telemetry can be that EDR sensor that sends up those native system events, or it can be some third-party data set, cloud collection, log set, whatever else it might be. The actions in those events that are sent up, and I'm not using the field action, I'm talking about like the description there, if you will. The what's happening are the types of things that you want to write a detection or response rule against. From an EDR perspective, our sensor events are the events that I would typically write a detection rule against. Notice in the example we talked about earlier, it was a DNS request that we were writing against. DNS request is a type of system event. Within the sensor's purview, when a user types in a domain name or when the system makes a DNS request out, a DNS request event is generated by the sensor. That's what I'm writing my detection and response rule against. Now let's keep with that example and let's say, well, Matt, if I'm looking for network connectivity in this case, why would I look for DNS request versus TCP/4 connectivity to an IP address? If I'm interested in every time a user is going to example.com, why wouldn't I instead look for every time their IP address or there's a connection to the IP address for example.com? Well, you're not wrong necessarily, but I'll tell you it depends on how you're looking for what you're looking for. And this little monologue that I'm about to go on is one of the most important aspects of writing the detection and response rule, which is what is the event that gives me the most bang for my buck, if you will, or without using any sort of euphemisms or idiom, what is the correct event to use? I like using network connectivity as an example because there's so many different ways of going through this. First and foremost, remember my original question. My original question was, I want to know every time a system connects to example.com or example.net. All right, well, in that instance, you are asking about a domain name. A domain name is typically what users will use because users don't memorize IP addresses. I used to run little trivia questions in some of my previous classes and ask folks if they knew. Everyone seems to have at least, I found 3 IP addresses that seem to be memorized across the board. Feel free and jump in the chat if you can think of what they are. The first one is 127.0.0.1. I take localhost as the first answer. There's another one that everyone always gets, and it has 4 numbers that I'm sure you're probably familiar with, and that's the biggest hint ever. But nonetheless, let's go back to our matter at hand. If I'm looking for network connectivity in a detection and response rule, there's multiple ways to go about it. I can look for the domain name, or I can look for the IP address behind that domain name. In this case right here, if my original question focuses around the domain name, then I'm going to want to write a detection rule against a domain name. Notice my TCP4 connection event doesn't include domain names. At the TCP layer, we don't get domain names. It's at the DNS resolution where the domain name actually comes in. So if I'm trying to track that user activity, that user typing in that domain name, I've got to utilize a DNS request. Let's go the flip side. Let's say I'm not interested in every time a user connects to example.com. I am interested every time a user connects to a specific or a range or a list of IP addresses. Let's just again say hypothetically, I want to know every time a user connects to AWS. It's a pretty big IP space that AWS has. So let's just say there's 5 IP addresses of interest. I know they're AWS. I don't know the names of the websites, but I do know the IPs of interest, or I know IPs that maybe malware reaches out to, for example. In this case, what I'm going to do is I'm going to say, I'm at a lower level in the network stack. Therefore, I'm going to be utilizing something like a TCP event or a TCP v4, v6, or a UDP v4, v6, depending on what it is I'm looking for. And I'm looking for that network connection being created. Now, let's go down even further and take a look. In this case, there's also a network connections event in this case, a network connections event that gets sent up. This is a little bit different. This is a list of network connections performed by a process. So it does give me a chance if I want to filter down a little bit further or have some process specifics behind it. But a lot of the times you're writing detection and response rules at a very high level to answer high level questions. Again, how many people are visiting example.com? That's a very high level question. So I would write my detection and response rule accordingly. Let's break outside of those examples for just a moment and let's take a look at some of the different events that are reported from the EDR sensor. We have everything ranging from operating system events to system events to sensor events as well. And there's a lot of capabilities in here. And the nice thing about having all these different event types is it allows you to think of different questions you might want to ask, again, of your telemetry that's coming in. So we have events or events that get generated for when a sensor starts up, when a sensor shuts down, when it is connected to the cloud. We have events for when processes are created, for when processes are terminated, for the environment variables that are brought in by a process. We've got processes that are associated with code identity. We've got modules being loaded like a DLL on Windows. We've got events for when those are loaded in memory, including the full file path that comes with them. I have sensor events for when files are created, deleted, directory listing information. I've also got insight into other intra-memory, so we can go super deep and technical into the system, and I can include when memory map are made or when memory handles are requested. I can go a step further, and I can look for different types of high-level operating system events. So I could go through, and again, this is something that you would do in coordination with the system. This is stuff that you would generate or you would ask the sensor, but I've got event types for when services come back. We've got event types for new documents being created, service changes, driver changes, volume mounts, unmounts, so on and so forth. Named pipes being created, new and open, data being dropped, HTTP requests, so on and so forth. The really nice thing about this, everyone, is with all these different event types, I can start to get really creative with my different rule types, and I can ask a lot of different questions of my sensors and of my systems, and I can get really specific with my detection and response rules. So I can ask questions, again, like how many people are visiting example.com. I can go a step further, and I can say how many people are loading PowerShell.exe, how many people are creating files in the downloads directory, how many people are deleting files from their documents directory, what types of requests are being made into memory. We can go a step even further and say when files are modified, when new files are created, when all sorts of registry changes happen and take place. We won't go through the whole gamut of Windows, Mac, and Linux forensics right now, but let's just say there are a plethora of events that take place on the system. And here at LimaCharlie, we want to give you the ability to write detections against all of them. Let's back up and talk about scope for just a moment. Matt, why on earth would we need to be able to detect against all these different types of things? Well, folks, I'll tell you right now, malware authors are some of the most creative bunch of individuals you will ever run into. They will find some novel ways to inject code, to run something malicious, to do something they're not supposed to be doing. We want to give you as many options as we can to go through and detect that type of telemetry. Quick shout out and plug to our podcast that we've got that's out there. I highly recommend checking it out. Inside of that podcast, we do talk about different types of threat actor events, different types of things that they do, and different intel reports. And we do spend a lot of time talking about threat actor TTPs, tactic, techniques, and procedures, or tools, techniques, and procedures. I recommend checking that out because it gives a lot of value towards our telemetry. That's the Cyber Defenders podcast. Highly recommend checking it out. That's my only plug for today, but only because we recorded a session yesterday and actually spent some time talking about threat actor methodologies, and I couldn't stop thinking about how would I detect this in LimaCharlie. It's these events right here. So if I take this discussion to kind of that next level, when I read a threat intelligence report, and I learn about a threat actor who maybe utilizes a particular type of download method or a particular type of exfiltration method. Maybe they bring a DLL onto the system. They load a DLL versus code injection. They utilize named pipes for connectivity. Maybe they create services, delete services, mount drives, unmount drives, all those things. When you go through and read those threat reports about all those different steps that adversaries do in order to run code or steal data or whatever it is, that's where you see this represented. That's where all of our events come from. Now, inside of LimaCharlie, not to go too far ahead here, but inside of LimaCharlie, there are also some what I'm going to call meta events. These meta events are generated by other things, meaning it may not be generated by the sensor or the system itself. It might actually be a third party or an add-on or some other type of generation being created. The first one I'll point to is WEL. WEL is a Windows event log event. Notice this is actually an event that is brought in from LimaCharlie by reading the contents of the Windows event log or reading the stream of the event log. The nice thing about this is I get my Windows event log events, my WEL events, right next to my native system telemetry. And let me offer a quick difference between the two here. We don't have a system event, and there isn't really an operating system event for a user logged in. Remember what I was talking about earlier about the MAT user logging in? There isn't a native Windows telemetry event that is user login, for example, in this particular case. Although we might need to go build that. But nonetheless, there is no kind of specific event that says user login if name equals MAT. The way to get around that is to read the Windows security log and look for event 4624, which is successful login of a user, or 4625, which is failed login for a user. So in this case, we do stream the Windows event log events in. Those are set up as an artifact collection rule. We also do offer, and we'll talk about this in just a few minutes, we also do offer Yara support inside of LimaCharlie. Yara is yet another regular expression tool or something along those lines. I forget exactly what Yara stands for, yet another pattern matching tool or something like that. But nonetheless, we do offer Yara support inside of LimaCharlie. We'll talk about Yara in just a moment, as I mentioned. But once a Yara hit is found, or once a Yara match is found, that actually will show up as a detection event as well. Or that will show up as an event inside of the system timeline. The nice thing about this is if I give you a third-party tool like Yara and I enable it and turn it on and we're using Yara to scan my environment, I'm not going to send you to another dashboard for Yara rules while all your telemetry is over here. We're going to bring everything into one place. All right. With that said, let's go back and take a look once again at some of our, finally, the last part of the detection and response rule we have not talked about, which is that path field. So we talked about the events. We talked about operators. The value is pretty straightforward. This is the thing that we're looking for. The only part of the detection and response rule we haven't broken down just yet is the path. And the path is the field, for lack of a better term. Granted, it's all in JSON, which probably makes sense, but it's the key or the value pair, the field that you want to match against. So in this case, what I'm telling this detection and response rule is, I want you to look at DNS request events. And if the domain name is example.com, fire a detection. If I head back over to my DNS request, notice my DNS request is pretty well structured JSON. It's got 4 events associated with it. It's got DNS type, timestamp, DNS flags, and domain underscore name. The domain underscore name is the field that we want to match against for this particular detection and response rule. And that's exactly how it's going to read out. The event, again, that parent DNS request event, sub domain underscore name, which is represented right here, that's how that rule is going to come together. So just to reiterate, LimaCharlie, I would like a notification every time a user connects to example.com. That's it. Pretty straightforward. That's going to be a DNS request. I want to match against the domain name field, and I want every time is. I want a full match. I don't want a contains. I don't want a partial. I want a full match of example.com. And that's it. That's how the basic detection side of things comes together. You may notice as I was describing this, I went down a couple of different roads saying, hey, here's a way to get more advanced. That's just to tease out some details about some other things you might want to look for. But let's stick with our DNS request to continue understanding how to break out these detection and response rules. So now we've built out our detection. Let's get to the response side of things. Remember, every time a system connects to example.com or makes a DNS request for example.com, that's what I want you to find. The next part of a detection and response rule is, what do you want me to do when I find that particular thing? A lot of times, detection and response rules are geared towards suspicious or malicious activity, so I just want you to notify me when that happens. In that case, and I've pulled up the different types of actions that are available, but in this case, what I want you to do is I want you to alert me. And alerting in this case is going to be represented by the report action. The way that the response section comes together in a DNR rule is, again, a YAML descriptor, and I'm going to write out a single or series of events, a series of actions that I want you to do if something is found. I can have one action or I can have multiple actions. And the nice thing about the actions is I can get really creative with the types of things I drop in there. So let's pause. Let's back up. Why would we be looking for users connecting to example.com? We've already written the detection rule out, but why would we be looking for this thing, right? That's the question. Why would we be looking for users connecting to example.com? I have no idea. Maybe it's a good site and I want to track internal visits. Probably not the best, most realistic example, but nonetheless, it's one there. Let's go the other route. Maybe it's a site that hosts malware. Maybe it is a blocked site, a site that I don't want my users to be using. Maybe it is an extremely critical data theft, ransomware related site. And if anyone hits this, I need to know immediately. Or maybe it's something I don't really care about too much. I'm just putting this detection rule in here because my boss told me to, but I don't really care if anyone visits it. I'm just doing my job. You notice how the degree of how much I care is what's going to change what I do inside of my response activity. I would say the way you write a detection and response rule is to ask that question. The way to write the response part of the rule is to say, what do I want next? What do I want to happen next if this detection actually happens? Let's go through and take a look at the different response actions that are available. And I'm looking over here on the right-hand side inside of the navigation pane. We have some pretty straightforward kind of platform-based approaches. The first one that we just saw mentioned in our detection and response rule was report. Remember back in the beginning when I pointed you over to this detections menu? This is where your report is going to show up. This is your basic detection. This is your basic set of alerts, if you will. Interestingly enough, if I specify something to be reported, I do have a bunch of different fields that I can control or I can change or I can add to here. First, I'm going to declare action as report. If I go back to my sample rule, you'll notice that's exactly what we've done. We've declared the action as reporting. And then in this case right here, I've also given it a name. If I look at my response action breakout, the name is, what do you want to name that particular thing? Or to make life a little bit easier, what do you want it to show up as over here in this detections window? Notice in this case, we've got detection rules such as private get off hours, Google update, get possible exfil, non-interactive PowerShell process spawned. Those are the names of those particular detections, the things that popped up. We also have some additional things we can add in there. Do I want to publish this response? Yes or no? I can set that to false if I'm working in draft. I can set a priority. I can also set freeform arbitrary metadata about this. So perhaps I don't necessarily want to just report it and name it. Perhaps I want to add in metadata that says created by Matt Bromley, comma, if detected, notify Matt. Well, that's certainly one way we could go about doing things. Of course, I would also probably want to automate that output, but we'll talk about that one in just a moment there. I do also have the ability to add or remove tags to a system. This is where I really think, or sorry, not to a system, but to a sensor that has a detection that's been fired. This is where I think that you can really start to flex on detection and response rules or the purpose of detection and response rules. As I mentioned earlier, I don't necessarily need to be looking for malicious activity. I could just be looking for a thing. So in this case, and I like this tag because it goes through of adding a VIP tag to a particular system, I could go the route of saying, hey, all of my VIP users are using Adobe Acrobat. I don't know. Let's just hypothesize here. All of my VIP users are using Adobe Acrobat, and I need to catalog those users. I could go through and create a detection rule that looks for Adobe Acrobat. And if that Acrobat instance is found, I could add a VIP tag to that system and have it live for 30 seconds. Or I could have it live for a day or a week or however long I needed to. The nice thing about that is what that's going to do is it's going to allow me to use tagging as a next step, as a form of potential subsequent detections and response, or as system classification. Let's go the side of a SOC or an incident response team, and let's say, again, I'll use my earlier example. Let's say example.com is a bad domain or a malicious domain. Anyone who's visiting example.com, I need to know about that system because it's associated with malware. Well, folks, I might not necessarily want to just keep running detections and keep exporting detections and keep deduping lists of CSVs and things like that. What I might do instead is I might say, you know what? Every time example.com DNS request is made, let's add a tag, call it systems of interest, if you will, and I'm going to keep that tag on there for a day. And then when it comes to data lookups and accessing data through the platform, I'm going to then base my searches off of the tag systems of interest and things like that. So a couple different ways you can use it to your advantage. We can add or remove variables. We can perform additional service requests. I'll talk about that one in a subsequent lesson of ours when we talk about extending the platform. Perhaps the one that folks are interested in the most is going to be, can I isolate the system? That's going to be isolate network. What happens there is the system itself is isolated from the internet except for communication to the LimaCharlie channel, LimaCharlie communication channel. And what that's going to do is it's going to prevent any other network communications from happening. This is typically used in cases of malicious software. If you've got a piece of malware that's beaconing outbound, or you want to contain a system or something like that, segregating it from the network or isolating it from the network is going to be the easiest way to go through doing that. And then last but not least, we've also got the wait option built inside of here. The wait option adds a delay before running the next response action. The cool thing about this here is it allows you to actually stagger different events if you want to. So let's say you wanted to, add a couple of tags, or you wanted to fire multiple different types of detections, or you wanted to task something additional to happen. You could use wait to kind of implement a pause in there. And because you're building a series of YAML descriptors, you can actually layer responses in if you want to. So I could, for example, say, if example.com is connected to, I want you to report it. I want you to add a tag. I want you to wait 1 minute, and then I want you to isolate it from the network or something like that. So lots of different things that we might be interested in detecting, or lots of ways we might be interested in constructing them. Again, this is LC101. I want to give you insight into what you can do. We will not drill down into every single capability or possibility, but just know that there's a lot out there. Coming back to our basic response rule in this case, in this situation or in this example, we're not doing too much. All I want to do is say, if that DNS request to example.com is made, I want you to just simply report. And if that happens, inside of our detections window, we will have a detection that says DNS hit example.com. And that will be a really easy way for me to zoom in on that particular type of activity. And that's it. That's a long description, a very long description of detection and response rules. Now, it may feel like a couple of times I went off on some tangents off to the side there. I think it's really easy to see just how powerful detection and response rules can be, and just how quickly you can start to do something with those detection and response rules, which means how quickly can I start to look for malicious activity? How quickly can I start to look for multiple types of malicious activity? How quickly can I write detection and response rules that give me really crazy control and insight over the environment? I'll give you an example. Let's go to the malicious side of things. I'll give you an example of one. We've got it actually in our detection and response rules, and I love using this one as something to walk through. This is a detection and response rule called productivity dropper. And I'm a huge fan of this one because it does a really good job of building out the types of things you'd look for in a detection and response rule, but it also does so with some pretty complex formats as well. And I'm not here for you to memorize this. I want to show you what a detection and response rule can look like, or what it can be. So knowing everything we know right now, I'm going to want to go through and understand exactly what's happening here. So first off, remember we have our events. What type of events are we looking for? But wait, Matt, you said we should start detection and response rules with a question. You're right. So let's ask the question here. I'm interested in every time a productivity app, so a Word, an Excel, an Acrobat Reader, a browser, anything that my users might use, I'm interested in every time a browser or a user application calls a command prompt, launches a PowerShell instance, calls a bat file, runs an additional exe, or any of those other types of things that I wouldn't expect to actually happen. Meaning, I'm interested every time a productivity app does something it's probably not supposed to be doing, aka likely insight or likely attacker activity or some sort of malicious code. What types of things am I going for? What types of events am I basing off of? I'm looking after process events. So in this case, we've got a list of new process and existing process. The existing process is a really, really nice event because it lets you go after existing processes, not just new ones that start after the sensor is installed. My operator is AND, which means every single one of my rules below has to match. And look at how detailed we get here. First operator, or first part of my rule set, is I want the operating system to be Windows. That's another operator we've got, is the operating system that is there. Operator, operating system, a lot of words stumbling over each other. My next one is going to be a case-sensitive match, a case-insensitive match. Case-sensitive false, I want you to match the file path, and I'm going to look for any one of these executables. You could probably get some familiarity breaking these out. This is Microsoft Word, Outlook, Excel, PowerPoint, Internet Explorer, Firefox, Chrome, or Acrobat Reader 32-bit.exe. Notice that we've hard-coded the names of the executables in here based off of common naming conventions. I've gotten rid of case sensitivity, so even if someone tries to run these in all caps, they're not going to get caught there. And notice I don't know anything about the path of where these are located, so we've used that matching regex to say, hey, I'm really looking for these keywords inside of the path, no matter where they are, but I know they're going to be at the end of the path. And then take a look at this. I'm also interested in what it has dropped, what it has spawned, the things that it has created. Remember, my detection rule or my question is I want instances where user productivity apps have spawned or created things that they shouldn't have. So we can use a with descendant rule to then drill down deeper into that process tree. And here I'm looking for, notice my operator changes, or, so I'm looking for instances of command prompts or execution of things like a DLL or an EXE or a BAT script or a PS1. And notice that down here, it's the exact same format as up here as well. I'm looking for a new document event pivoted against the file path, and my regex is going to look for any of those file extensions of interest. Now, this is a really complex rule, especially for like just a basic starter 101. So I won't go through it in like, we won't break out every single line, but the nice thing about it is we don't really need to, because once you understand the basic format of a rule right here, which is what are you looking for? What type of event do we look for it against? Do we have any operators we need to include? All we're doing is washing, rinsing, and repeating that approach. Look at this. At a high level, this is a question. What are we looking for? What types of events are we looking against? What are we matching for? I include my events of interest, and then we get into the rules or the things that we're firing. And after all those 23 lines of complexity, all we're going to do is report it up and say, boom, we found a productivity dropper. We've got something of interest to look into. So lots of takeaways there. I want to go back to my original rule, and I want to use this example to maybe hammer home some final points here. First and foremost, detection and response rules are the easiest way for you to gain insight across your telemetry and figure out what's happening inside of your environment. We can use it to find activity in general. We can use it to find threat actor activity, user activity, anything along those lines. We can also use it to just gain information about the environment. As I mentioned in the example when I talked about it countless times, doesn't mean example.com is malicious in this case. Maybe I'm just curious about connectivity to that site for other business reasons or other operational reasons. Remember, when we're writing a detection and response rule, we've got two parts to it. What are you looking for, and what do you want to do when you find that particular thing? Detection and then response. In LimaCharlie, those things are brought together inside of a single DNR rule. We do not write detections and then push them off to an automated SOAR platform or something else that then has response actions over here. We want to keep those detection and response elements together. And last but not least, while we did spend a lot of time understanding the mechanics of writing a detection and response rule, if it still feels a little bit above your head or you need to move a little faster than what we described, remember that we've also got curated rule sets published available inside of the marketplace, where you can automatically free and immediately import Sigma and Snap Attack community rules. There's also a managed rule set from Soteria and some generic macOS rules. And then finally, SOC Prime has an API integration available as well. Last but not least, or should I say perhaps maybe in summary, you do not have to go into this journey of detecting suspicious activity alone. Create an organization, install a sensor, turn on Sigma rules, and in a matter of literally about maybe 30 seconds to a minute, you've gone from a blank organization to now an organization with hundreds of rules available, ready to detect any malicious activity that it may find. And that, folks, is Detection and Response Rules 101. Again, we went down multiple different roads. A huge thanks for joining me here today. A quick note for everyone watching, we will be out and about in the future. If you're going to be at RSA in San Francisco, I definitely recommend coming to check us out. That's going to be, I think, the week of April 22nd or something. We'll be out there. And then second, the LimaCharlie team, a few of us will also be at ThoughtCon in Chicago. That is in May. Highly recommend you come and see us if you'll be at either of those. And then lastly, we'll of course be at Black Hat in Vegas as well. We might pop up at a few events between here and there, but if you're around, if you see the LimaCharlie logo, the shirt, you know someone, whatever it is, by all means, give us a holler. We'd love to see you, love to say hi. All right. Watch the channel, watch our community Slack for the next LC101 course where we talk about extending the platform and outputting data. Hope you had fun today. As always, bring any questions or anything else you might have into the chat, into the Slack. Happy to answer them there. Thanks, and I'll see you on the next one.